Hello everybody, I am Syed on Maths Online. Today we will be discussing about binomial distribution. So before that we'll just try to see the binomial expansion. We know the binomial expansion is x plus a whole power of n to be equals to x power of n plus nc1 x power of n minus of 1 into a plus nc2 x power of n minus 2 into a square plus nc3 x power of n minus 3 a cube and so on, and the final term will be a power of n. In the same way, suppose if I try to replace the value of say x by q and replace the value of a by p, then the binomial expansion becomes q plus p whole power of n will be equals to. So now if I, wherever x is there, just replace it by q, and wherever a is there, just replace that by p. So we will be getting the value as q power of n plus nc1. It is q power of n minus of 1 into p plus nc2 q power of n minus of 2 into p square plus nc3 q power of n minus of 3 into pq. And if you go on continuing, maybe let me write down one more term over here. In case if I write say nc some x value here, so let us try to observe. So nc1 here, so nc2, nc3 and so on, I'm writing it as ncx, then q power of, you can see n minus of. If you try to observe, if it is 1 here, you get n minus of 1. If it is 2 here, you get n minus of 2. If it is 3 here, you will get n minus of 3. If it is x here, you will be getting n minus of x into p power. If you try to observe here, it is 1, therefore p power of 1. It is 2 here, it is p power of 2. It is 3 here, therefore it is p power of 3. Here it is x, therefore it is p power of x. And if I continue it, and if I write down the final term will be equals to, it is p power of n. So now if I try to just choose this expression and write down this expression to be say equals to p of x, so we will be getting p of x to be equals to ncx, it is q power of n minus of x into p power of x. This expression is called as a binomial distribution. We know for this represents p of x, the probability function, and for probability function we know that the condition, this probability summation of p of x should be equals to 1. So now if you just try to plug in this value of p of x over here, we'll be getting summation of ncx q power of n minus of x into p power of x is equals to 1, where the value of x will be equals to from 0 to say n. Now suppose if we put the value of x to be 0 over here, we will be getting nc0. Let me write down, say nc0. It is q power of x value is 0 over here, so we will be getting q power of n into p power of x value is 0 plus the next value of x will be 1, so we'll get nc1 q power of n minus of 1 into p power of 1. The next value of x will be 2, so nc2, it is q power of n minus of 2 into p power of 2. The next value of x is 3, so nc3, it is q power of n minus of 3 into pq, and it goes on, it continues, and the last term will be equals to again last term for x is n, so nc n, it is q power of n minus x value will be n into p power of n. If you try to observe, this nc0 value will be equals to just 1, as p power of 0 value is also equals to 1. So you got the value of q power of n. There is nothing but this first term, q power of n. Next value nc1 q power of, just try to observe it. This nc1 q power of n minus 1 into p, nc2 q power of n minus 2 into p square, and the final term comes out to be ncn, its value will be equals to 1. That is q power of n minus n is 0, so q power of 0 will be 1. So you get p power of n. So this expansion is nothing but your q plus p whole power of n. So it is q plus p, it is whole power of n. It is equals to 0, therefore this value is also equals to 0. So this whole expression is equals to q plus p whole power of n, and its value will be equals to, its value is equals to 1. Or in general you can write this q plus p will be equals to 1. So this case is always true, where this p represents the probability of success and this q represents the probability of failure. Probability of failure. So we always see the sum of the probability of success plus probability of failure will always be equals to 1. Now let's try to take an example and see how this will work. Suppose if you take a coin and toss the coin, and the probability of success that you want. So you are calling, when I toss a coin, suppose if you are calling as a head, that means your probability of success will represent head. If head comes, then naturally tail will not come, so we'll take the probability of failure to be equals to tail. So what is the probability that you will be getting a head, and what is the probability that you will be getting a tail? There is always a 50-50 chance of getting a head and tail, so 50% represents 1 by 2, 50% represents 1 by 2. So if I just add these two expressions as p plus q, so that will be equals to p value is half, q value is half. So half plus half will be how much? It will be equals to 1. So you can always see that p plus q will always be equals to 1. We will try to see mean and standard deviation of the binomial distribution. You know the formula for the mean. Mean is equals to the summation of x into p of x, where the value of x is running from 0 to n. The summation of x is equals to 0 to n x into, already seen that the value of p of x over here. So this is your value of p of x, it is ncx q power of n minus of 1 into p power of x. ncx q power of n minus of x into p power of x. If we try to rewrite the summation of x is equals to 0 to n x into, we can expand this one ncx. The general formula that we have is ncr, the combination formula, it is n factorial divided by n minus of r factorial into r factorial. This is general formula. Now if you rewrite this formula, it is n factorial divided by, it is n minus, so in place of r you have x, so n minus of x factorial into x factorial. If you try to rewrite this one, it is summation of x is equals to 0 to n is x into. Now let us try to prove this one and rewrite this n factorial to be n into n minus of 1 factorial. You can write in this way. And x factorial, let me write this x factorial to be equals to x into x minus of 1 factorial. N minus of x factorial as it is. I'll just rearrange this expression. And This is q power of n minus of x into p power of x. So this value is q power of n minus of x into p power of, try to observe here, x is expressed in the form of x minus of 1, so you can write this as x minus 1 and plus 1, which will be equals to the summation of x is equals to, I'll just try to cancel out this x and x, and now because you have cancelled out one value of x, so then the value of x starts, you have to move one step further, x is equals to 1 to n. So this I can write n into n minus of 1 factorial divided by, it is x minus of 1 factorial into, now because you have n is written in the form of n minus of 1, x also in x minus of 1, so here also we will try to write it in the form of n minus of 1 and x minus of 1. So for that I'll just try to add 1 and subtract 1. So this q power of, here also I'll try to add 1 and subtract 1. So this can be written as p power of, I'll just try to separate this one. I can write p power of x minus of 1 separate and p power of 1 separate. P power of 1 is p itself, which should be equals to, now this n and p I can take it outside. If I take np outside, I get summation of x is equals to 1 to n. This is n minus of 1 factorial whole divided by, this is x minus of 1 factorial. Now group in such a way that you have to get n minus of 1. So I'll just try to group this one, n minus of 1. Now I have to group this x and 1. So if I take minus sign outside, what will be left out? X minus of 1. That's q power of, here also it is n minus of 1, you can group n minus of 1. Here in these two terms you can take negative sign common outside, you'll get x minus of 1. This is p power of x minus of 1. This p is already taken outside. Which will be equals to n times of p. Now if you try to observe this expression over here, this is similar to this particular expression that we have, ncr is equals to n factorial divided by n minus of r factorial into r factorial. So in place of n factorial, you are having the expression as n minus of 1, and here if you try to observe, n minus of r factorial is, n value is n minus of 1, your r value is x minus of 1, into r factorial represents your x minus 1 factorial. So you can write this as n minus of 1 c x minus of 1, right? That's the expression you have. So summation of x is equals to 1 to n will be as it is, this q power of n minus of 1 minus x minus of 1 into p power of x minus of 1, which can be further written in the form of n times of p. What does this summation represents? So if you try to observe this summation value, the summation value will represent q plus p. So this represents q plus p whole power of, what should be the power? So in power should be n, but here in place of n you are having n minus of 1, so it becomes n minus of 1. So this, because the summation is written in the form of q plus p, because I have already shown you over here the summation which is there, we have expanded that summation and written it in the form of q plus p. So whenever you try to expand that summation value, you can rewrite that in the form of q plus p whole power of n. So that is what I am doing over here. It is q plus p whole power of n. But what is q plus p? Q plus p value is equals to 1. So which is nothing but n times of p. So we got mean mu to be equals to n times of p. Let us find out variance. variance v is equals to, it is summation of x square p of x, where the value of x will be equals to 0 to n minus of mu square. Let's take this as say equation number 1. Let us first try to evaluate this first expression separately. So if I consider only that term as summation of x square p of x, x is equals to 0 to n, that will be equals to the summation of x is equals to 0 to n. But to evaluate this, let me subtract x and add x into this p of x as it is, which will be equals to the summation of x is equals to 0 to n. So if we try to group these two terms, so in this x is common, so if I remove x common, I will be left out with the x minus of 1 plus this expression x as it is times of p of x. So multiply this p of x inside, you will be getting summation of x is equals to 0 to n x into x minus of 1 into p of x, plus again multiply, it is x times of p of x. So try to apply the summation for the first term as well as for the second term. We'll get summation of x is equals to 0 to n x into x minus of 1 into p of x, plus summation x is equals to 0 to n x into p of x. Now you can replace the value of p of x over here. It is summation of x is equals to 0 to n x into x minus of 1. P of x value is ncx q power of n minus of x into p power of x, plus the summation of x into p of x. You already seen in the first case, mean mu is equals to summation of x into p of x. So in place of x into p of x, I can replace the value to be equals to mean mu. It is equals to, it is summation of x is equals to 0 to n, it is x into x minus of 1. ncx, you can use the combination formula, it is n factorial divided by n minus of x factorial into x factorial into, it is q power of n minus of x into p power of x, plus mean mu. We have just calculated the mean mu to be equals to np, so you can replace mean mu to be equals to np, so it becomes n times of p, which will be equals to the summation of x is equals to 0 to n, it is x into x minus of 1. So because you are having two terms over here, x into x minus of 1, n can also be expressed in the form of n into n minus of 1, one more additional term n minus of 2 factorial, whole divided by denominator n minus of x you are having. So here also n minus of x factorial into x factorial can be written as x into x minus of 1 into x minus of 2 factorial. It is p power of n minus of x. It is p power of, because you're getting x minus of 2 over here, you can subtract 2 and add 2, and this plus np will remain as it is. Or further, if you try to simplify, it is summation of x is equals to 0 to n. If you try to observe this x minus of 1, x minus of 1 will cancel out. Because you have cancelled out two terms, you have to move 2 steps ahead here. So you'll be getting summation from 2 to n. So here you have n into n minus of 1 into n minus of 2 factorial whole divided by, because you're getting n minus of 2 factorial over here, so here also you'll try to get n minus of 2. So n minus of x you subtract 2 and add 2 over here. So if you add 2 and subtract 2, it's factorial notation as it is. So here you have x minus of 2 factorial. This value is q. So this q power of n minus of x, you add 2 and subtract 2 over here. This can be written as p power of x minus 2 separate, and you can write p square separate, plus this n times of p separate, which can be written in the form of, there is summation of x is equals to 2 to n, it is n into n minus of 1 into n minus of 2 factorial whole divided by, you can group this n minus of 2, so it is n minus of 2. Again, in these two terms, if I take a negative, I'll be getting x minus of 2, that will be factorial, into this is x minus of 2 factorial. So here you can group it, it is q power of, you can group this n minus of 2. So n minus of 2 minus of, here if you are taking negative sign, you'll get x minus of 2. So this p power of x minus of 2 as it is, p square as it is, plus n times of p, so which will be equals to, you can take this n into n minus of 1 outside, and also p square can be taken outside. So you have summation x is equals to 2 to n. Here you are left out with n minus of 2 factorial divided by, it is n minus of 2 minus of x minus of 2 factorial into x minus of 2 factorial into, it is q power of n minus of 2 minus x minus of 2 into p power of x minus of 2 plus np you get. That will be equals to n into n minus of 1 times of p square into summation of x is equals to 2 to n. Its value is nothing but NCR form, so you can write it as n minus of 2, because n minus 2 is there, and to see what do you get, this value x minus of 2, it is q power of n minus of 2 minus of x minus of 2 into p power of x minus of 2 plus n times of p, which will be equals to n into n minus 1 times of p square. So try to see this summation. This is nothing but ncx q power of n minus of x into p power of x form. This is summation of px form, which can be written in the form of q plus p whole power of n. So therefore you can write this q plus p whole power of n, but in place of n you have n minus of 2, and this plus np will be as it is, which will be equals to n into n minus of 1 into p square, but we know the value of q plus p will be 1, so it is 1 power of n minus of 2 plus np, or it is n into n minus 1 times of p square, this is 1 itself, plus n times of p. So this is the expression that we have got for the equation number 1 that we have solved here. We have solved this expression for this. This is nothing but your summation of x square into p of x. You have calculated this value. So we need to plug in this value back over here in equation number 1. So equation 1 will imply variance v will be equals to summation of x square p of x is n into n minus 1 times of p square, plus you have n times of p, right? And further it is minus of mu square value is there, minus of mu square, which will be equals to Let us just try to multiply it. If you multiply n inside, it will become n square minus n times of p square, plus it is n times of p, minus we know the value of mean mu to be equals to np, so it is np whole square. Or further, if I try to multiply n square into p square, is n square p square minus n times of p square plus n times of p, minus it is n square p square. So you can see that this plus n square p square minus n square p square will cancel out. So in these two terms, you can see that n times of p is common, so np is common. So what is left out over here? It is minus of p. np is common, you are left out with 1, or you can write it as np. First let me write the positive value, next the negative value, 1 minus of p. But we know this result, p plus q, its value is equals to what? Its value is 1. So can I write this as q is equals to 1, take this p on the other side, is 1 minus of p. So can I rewrite this 1 minus p in the form of q here? So we'll be getting np, its value is nothing but q. So therefore you got the variance v to be equals to npq. Standard deviation sigma is nothing but square root of the variance v. Therefore if you write, sigma will be equals to square root of v value is npq. So therefore we get the standard deviation as square root of npq. So that is the mean and variance and the standard deviation for the binomial distribution. That's all we have for today. Thank you.